all to the lecture series on curvature. Myself, Dr.N.Sugantha Meena, working as an assistant professor in the Department of Mathematics, V.H.N.S.N.College, Virudhunagar. Before going into the definition of curvature, let me recall what is meant by a curve. And the curve is defined as a continuous smooth line that is having bends and turns in it. And here are some examples of a curve. Look into this parabola. The parabola is a smooth continuous line and it has a bending here and then it turns upwards. So parabola is a curve. It is a continuous smooth line that is having bend and the turn. And some more examples are hyperbola, circle and ellipse. Now let us get into the definition of a curvature. And what does the word curvature means? The word curvature means the amount by which something is bent. The bent amount. The amount is a mathematical value by which something is bent. Now I am associating this with my curve C, and if I ask a question how much the curve bends, the answer is a curvature, and it takes real values. And we also note that if the curve bends or turns, there is a change in the direction of curves. That is obvious. If a curve bends, there is a change in the direction. So, to measure how much the curve bends, it is enough if we measure how much the curve's direction changes. Right? And that should be over a small distance. We have to measure the direction change over a small distance in the curve. So, let me give some picture representation, some graphical representation to this. This is my x-axis and this is y-axis and this is my curve C. And let A be a fixed point on this curve and P be any arbitrary point on this curve C, and the arc length is S. Now our aim is to find the curvature at the point P, and for this we have to check how the curve's direction changes at P. To find the direction in which the curve changes, I am drawing a tangent at P, and that makes an angle pi with a positive direction of x-axis. And after a small displacement delta S, after a shift delta S, the new position of the point P is Q, and the corresponding tangent also changes its direction. Here the tangent at P is facing this direction, and after a bending, the curve at Q, the tangent at Q faces this direction. So there is a corresponding change in the angle, and this makes an angle pi plus delta pi with the x-axis. So when you are measuring the angle between the two tangents, that is nothing but delta pi. So with these representation, now let us give a mathematical definition to the curvature. The curvature is the rate of turning of the tangent. We have seen that to measure the change in the direction, we have drawn a tangents and see whether how much the tangent turns. So the curvature is the rate of turning of the tangent with respect to the arc length, right? And now we have to give a proper formula for this. And can we measure the curvature directly? If we can't measure directly, we express it as a ratio of some known quantities that also dependent quantities. We can't measure the curvature directly as we measure the distance, as also measure the weight. We can't find the curvature directly. So we are expressing it as the ratio of two known things, delta pi by delta s. That is the change in the angle with respect to the change in the arc length. Now we have to give one more condition, that we have to find the curvature over a small distance. So this delta s should be a small quantity, that is, it must be nearer to 0. So we are finding the curvature as the limiting value of the ratio with delta s tends to 0. And this curvature is denoted by d pi by ds. That is equal to limit delta s tends to 0. This delta s must be a small quantity, as we have to measure the curvature over a small distance. This delta s is nearer to 0, and this limiting value of the ratio delta pi by delta s is known as the curvature at that point. And let us see some of the applications of curvature. The curvature is used to determine the turning points of the railway tracks and the paths of the road in the hilly areas, and also in the construction of bridges and roller coaster designs. And it is not only used in engineering field, it is also used in medical fields. Usually the spine should be straight. If there is any abnormal curvature in the spine, we have to measure how much it deviates from the original, and correspondingly we should treat the patients. So to measure the abnormal curvature in the spine, we are using curvature. And it is all has many application in physics, engineering. It has many applications in our day-to-day life. And so there are some insights here to get a better understanding. The curvature of a straight line is, as we know that the curvature measures the how far the curve bends. In the straight line there is no bending, so the bending is here is 0. So the curvature of a straight line is 0. And in the curvature formula, d pi by ds, s represents the is it deviation, arc length or angle. We have defined curvature as the rate of turning of the tangent with respect to the arc length s. So here s represents the arc length. And the curvature of a curve can take only positive values or only negative values, or it can take any value, 0, positive and negative. The curvature of a curve can be negative also, and the sign depends upon in which direction the curve bends. So the curvature may take 0 for a straight line as we seen, and it can take also positive and negative values. And fourth question, if the curvature is a constant, then the curve C is. Let us reframe this question. If can the curvature be constant? That in other words, I am asking, the curvature is same for all the points of the curve. You please think of this question, and let us see the answer in the next lecture. And here is the summary of today's lecture. We have defined the curvature as the rate of turning of the tangent with respect to arc length, and we have symbolized this curvature at the point P equal to d pi by ds, and we have seen some of the applications. In the next class, we have to see the definition of the radius of curvature and center of curvature. And today's summary is the definition of curvature with its applications. Thank you.